How many people have had exposure to Kubernetes before? Excellent. This is awesome. We're not where we need to be. Put it on the right slide, maybe. Excellent. How many people have used Kubernetes before? Great. So perfect. So in my talk, we're going to talk about extending Kubernetes with operator framework, the operator pattern. Kyle's talk was fantastic. I'm going to add on to that in the definition of Kubernetes. Because if we talk about extending it, we need to talk about where it is, what its limits are, and also kind of how it functions a little bit internally, which I think will be pretty exciting. We'll talk about ways to develop on the platform using the internals of Kubernetes more than just running your applications on top of it. Sound good? Good. So real quick introduction. My name's Aaron Spiegel. I work for a company called Dell EMC. I work on a product called Elastic Cloud Storage, where we're using Kubernetes. We're using operators. It's a private cloud S3 compatible object store. So it's for when you want to run Amazon S3, but not at Amazon, kind of anywhere you want to. KC native, and still live here, luckily. So as I was looking at my topic, I thought, and I put this slide together as the first step, right? I thought, that's a lot of words, big, giant, white words. And so I thought, man, I need to fill these out. And at first I thought maybe a progress bar, but it's going to be a crappy progress bar because I'm not going in order of these words. But I'm going to use kind of the title slide as our agenda. This is what's going to drive us. These are going to be kind of tell you what piece of the talk we're talking about. And so to start, I told you it's not a progress bar. I'm going to start second word from the end because that's the way I do. So let's talk about operators. An operator obviously is a metaphor, but it's a useful metaphor. When we're talking about this operator pattern, we're modeling off of something in the real world. So an operator is an expert in some system. They've got a specialized level of expertise. They need to be able to understand the platform or the system that they're administering, and they need to be able to react dynamically to what's happening. And this is analogous to people that are operating these platforms. And it's a little bit of a different way to think of automation. If we think about deployment platforms and configuration management and the different ways that we automate things, this operator is a little bit higher level of complexity using a little bit more sharpened tool than what we started with, because we've got this great new fantastic tool in Kubernetes. And probably the most important aspect is that operators, the real people that we're emulating in this metaphor, are able to perform these complicated multi-step procedures, deal with failures of those things, and so forth. If that's a little bit too abstract for you, in the type of operator that I'm talking about in a Kubernetes context is literally, it's a Docker container that you're going to run. You're going to run it in Kubernetes. That's a controller. We'll talk about what a controller is. But it's the container that I'm running. And it's a custom resource, which is a new type of noun in Kubernetes. We'll talk about that too. Also, kind of in the concrete side, an operator in Kubernetes context is a software package format, kind of like an RPM, but with some differences. It's designed for those complex systems where you need a specialized operator to run. And it leverages Kubernetes as not just the place where I run the automation, but also it uses the internals of Kubernetes to facilitate that. So it's really extending the platform. One of the quotes that I really like from Alan Kay is that perfection in software development is when I bring my platform up to the program as the program is coming down to the platform. And I think one of my favorite things about operator framework and about operators in general in Kubernetes is that we're really exercising that model where we're bringing the platform up and we're bringing the software down and we're meeting somewhere in the middle to create that nice balance. So the next thing we want to talk about is Kubernetes. Kyle's talk was great. I'm not going to redo it, but I'm going to give you a different lens, a little bit of how Kubernetes acts on the inside. And so brace yourselves. I have a really complicated architecture diagram, but don't be scared of it. So if you have something simpler, come and find me after. I'd love to have a simpler internal architecture of Kubernetes than what I've got. But this we're going to have to walk through, complicated architecture diagram that it is. In Kubernetes, everything that Kubernetes is made up of is on this slide. So all the things that make this complex system work are in these three nouns. You have resources. These are the nouns of Kubernetes: pods, stateful sets, daemon sets, nodes, events. All of the things that make a Kubernetes cluster are resources inside that cluster. Everything that's ever happened in the lifetime of those nouns is in the event stream. These nouns, by the way, they're in etcd, in the core state of your Kubernetes cluster. Same with the event stream. Events are resources, but they are resources that describe everything that's happened: a node failure, a node creation, a pod creation, daemon set, etc. And then you have controllers, which are specialized containers that are designed to act on that event stream to do things with the resource. So let's dig a little bit deeper. So resources, I saw a lot of hands. Most of you guys are comfortable with this, but I want to make sure everyone's with us. These are the nouns that you should be familiar with. And the purpose of these nouns are really to abstract all of the things that actually take to run an application, and in some ways to run a data center. Maybe not everything, but everything that Kubernetes needs to care about to run your application are in some noun in a Kubernetes resource. Nodes, events, as I mentioned, services, load balancers, ingress rules, so like how a web server can get to an app, port definitions, all of those sorts of things are part of that spec. And usually, most of the time that Kubernetes users get exposure to those things, it's because you're using kubectl apply. It's not kubectl. It's kubectl apply or create to go shove some YAML into etcd. So then we have our event stream. The event stream, also in etcd, it's an append-only log of all of the things that have ever happened. A new pod was created, and it couldn't get run. That's an event, right? It did run, and that's an event. And by being this single append-only system, you can intune all of the states of that platform. And most importantly, from the developer, you can decide what state the cluster is in and what state it should be. But this is, you create new events anytime you as the users of Kubernetes do a thing, you're creating new events, but also the cluster creates its own events as things happen. And then we have these controllers. And the controllers are these special pods. Wow, you guys all turned orange. The controllers are special pods. You'll see them in your kubesystem namespace that are designed to react to these events, to intune from the events what is the current state and what is the desired state, and what action should it take to transform that cluster from the current state into the desired state. So if we put them all together, again, very technical architecture diagram for you guys. I have my current state, and my current state is I have 1 log and 3 bricks, and 1 ore, 2 sheep, and wheat. And the job of the controller is to go transform that to say, okay, what I really want is 2 bricks, so the controller itself will subtract 1 brick. I use natural resources to show resources, but these could be services and load balancers and pods and stateful sets, etc. So how does this relate to operators? Because we need to get around to operators too, right? The operator is a custom type of controller and custom types of resources. So if I create an operator that's able to manage and maintain roads and settlements, then I have that special type of controller that can say, I'm going to take non-existent homes and settlements and go turn them into existing ones or subtract them or whatever it needs to do. And I kind of chose these also because the settlements and the roads, they're made up of these natural resources that I started with. And that's often the case, not always the case, but that's often the case with operators as well, where I'm taking pods or I'm taking stateful sets and I'm creating higher levels of abstraction on top of those with my operator. So let's talk about extending Kubernetes. Again, like we started with the operator, went to Kubernetes, now I'm overlapping 2 words, so this is a terrible progress bar, but it makes a decent agenda, I hope. First of all, you should ask, why do I need to extend Kubernetes? Kubernetes is capable of lots of awesome things, but it doesn't do all of the things. But one of the things that makes Kubernetes the most special is that it can be extended really easily to do all of the things if those things need to get done. So what if the thing that you want to control isn't strictly an app or it doesn't live inside Kubernetes today? Maybe it's a business or a financial system that's external, and I want to go create a project inside a billing system, or I want to go talk to some external service that should be rewritten and run inside Kubernetes, but it doesn't yet. And so I want to go talk to that. Or I want to control something that's physical or more specific to me. I want to control an RMM or an environmental system. Like all of those things can be controlled, and they require some customization of the platform. Some other kind of common reasons to use operators is I have a platform that's complex. Maybe it's made up of more than one stateful set and more than one deployment. And I want to abstract that complexity for my end users that want to use my software. And so I'm going to create an operator in order to manage that software product. I'm with Dell EMC, we're a data company. We think about data a lot. And when you're dealing with data, sometimes you have to be careful so that you don't corrupt it or lose it, because customers generally don't like it when I corrupt or lose their data. And so that means sometimes I need to take multi-step procedures. I need to evaluate the data. I need to replay it. Relying on the default Kubernetes behaviors may not be the best thing for me to make sure that I don't lose your stuff. But I don't want to give the impression that we should make everything into an operator. You shouldn't. First of all, things that work in Kubernetes just fine already. You don't need to reinvent anything. But also, operators need permissions to work on your cluster. They're replacing an end user for lots of the things that they're doing. So they need the same permissions that administrator would need for deployments or stateful sets. And these can be scoped in the role-based access that you assign them. But that's a security consideration that you need to be thinking about and paying attention to. What permissions am I delegating to this piece of automation that I'm adding to my cluster? And also, as a developer or as a product team, anything that you develop is going to be tightly integrated and tight-knit with Kubernetes. So you're not going to get a ton of reuse if you're thinking about deploying to multiple platforms in addition to Kubernetes. I think Kubernetes is the end-all, be-all of everything, and why develop for anything else? But that's today. Who knows what I'll think tomorrow? There's lots of examples of operators. It's a very popular subject matter, particularly among people that are working with data like me. Also, Prometheus, which is a relatively complex system and requires a lot of resources to be created. So there's a Prometheus operator, Vault operator, Kafka. I put WebLogic over there because I was surprised that Oracle made a WebLogic operator. I mean, that's great for them. No, I don't. That's not sarcasm. It is, but also Kubeflow, which is like a Kubernetes TensorFlow thing. It's like, wow, I can, in an automated way, I can leverage the Kubernetes automation in order to create and drive and append my TensorFlow system, which I think is pretty amazing. And also OpenStack, thinking about all of the control plane piece that it takes to run virtual machines and be able to have that OpenStack control plane deployed in a more automated way, because managing OpenStack can be a pain. It's great to have these advances in automation come to platforms at the hypervisor level. At Dell EMC, I mentioned we're working with operators too. We open source literally this week our Zookeeper operator. We have Zookeeper at the core of a number of our products, both commercial and open source. And we use it for exactly some of those reasons, to protect your data, manage and maintain your data, make sure that we don't lose it for you. Also, we have an open source streaming product. Think of it as an open source alternative with some better features to Kinesis or Google Cloud Dataflow, alternatives for running streaming storage. And that's a relatively complex stateful system that manages multiple deployments and stateful sets, and also has to manage your persistent storage in special ways for a single once delivery append-only log system. And we have other stuff that we're working on. You can intune some of that by the part of the business I work in that's also working with Kubernetes that we haven't announced yet. So let's talk about more concrete stuff. What are these resources that I'm talking about? How to extend Kubernetes? How would you do it? Well, the first thing I need a Kubernetes noun that allows me to define new Kubernetes nouns, which is fantastic. Like, I just love it. This is probably my favorite part. So that's what we have here. For those that haven't coded in YAML but are interested in Kubernetes, you're going to see a lot more. There's a custom resource definition is a special type of Kubernetes noun that lets you define new nouns. So in this case, I'm defining a new noun that's called demo. It's of kind demo, and so when I add this, I can use kubectl get demos, and I'll get all of the demos that I've deployed to my. I can do a kubectl apply, and I can create a new demo with a new type of spec that's specific to the thing that I'm creating. So if there's customer inputs that they need in order to create a demo type resource, in my case, I didn't add any. But if I need customer inputs to define, maybe the name of the demo, or maybe a URL to it, or whatever inputs my customer needs in order to define that use, I can define in that spec. And this is what the customer will create when they're using my custom resource. And then the last part I mentioned to you before, you need a controller to act on that custom resource. And this is an example of that controller. Well, and this is Go. So if you're wanting to extend Kubernetes and you don't read Go yet, buckle up. You're going to see a lot more. Most of it's not all in Go. It's all in Go. So here I'm creating a watch, and this is actually from Operator Framework. I'm creating a watch. The most important lines here is I'm telling my controller that you should watch the event stream, and for any time that you hit the event stream that's a type of my resource in a namespace that I'm watching, then you should handle it. And I can subscribe multiple watchers, and I can subscribe multiple handlers, and then I tell this thing to run, and this is the entry point of my container that is going to react to those events as they come in off of that event stream. So just like the controllers that are part of Kubernetes, that are part of the platform in the way that works, my software automation here is designed to intune the desired state, compare that with the current state, and make the necessary changes to convert current state into desired state. So my software running on top of Kubernetes is using the same mechanisms that Kubernetes itself uses to manage itself, which is wonderful. I think it's wonderful. So now, Operator Framework. Like, we'll get to the specific of what this framework is and how you might use it. The first bullet should be pretty clear. I don't even know why I put it on the slide. It's a framework for writing operators. It's written in Go. There are others that are not. The primary contributor and sponsor of the project is Red Hat. A lot of the team that came from CoreOS that had advanced this idea when they were CoreOS is now with Red Hat, of course, or not of course, but they're now with Red Hat, and they're the primary sponsor. There are some other players that are out there in this ecosystem, MetaController and KubeBuilder, which are both Google projects from different teams within Google. They're also both written in Go. Controller sample is kind of a do-it-yourself model where it gives you a sample of a controller that you can duplicate, and you can write all of this automation from scratch. And if you're tied to Java, if you must use Java for what you're doing, which happens, then you can use Fabricate, which isn't strictly an operator framework, but it gives you the libraries that it takes to perform these watches and perform these actions. So let's show it in action. So I've got Go installed. I've got the Operator SDK installed from Operator Framework, and I'm going to go create a new project in Go that is going to be the root of my project. I'm going to create the controller and the custom resource that it takes to do this. I've sped up the fetching of the dependencies. That takes about 45 seconds on my machine. I've sped it up to about 10 seconds And it's going to initialize my Git repository, and now I've generated all of the code that I need to get started. And if I look at the software, there's really three main places where the software lives. There's my type specifications under package APIs. There's my handler that's going to go work with those options. And there's my entry point, which is basically the same code that I showed you before. Now I can run operator SDK build, and this is literally going to build a Docker container for me with this tag. So if I wanted to push this up to Docker Hub, I could do Docker push that tag, and it would push it right to Docker Hub or my private registry, wherever I happen to be hosting it, or some other public registry, it doesn't matter. And it'll create some tools where I can go deploy that on top of Kubernetes. So what did that make for me? It made my entry point, as I mentioned. I won't go back through the code, but just enough to say, when I handle one of those events that comes in off of the event stream, I'm going to fire off my handle command that's inside this handler, which is this bit of code. And I'll break this down for you guys also. Everyone can see this okay, right? It's a giant screen. Okay. So I'm going to receive this event, and I'm going to figure out what type is that event, because it could be multiple types of resource that I'm watching for. In this case, it's a demo resource. And when I receive that demo resource, I'm going to do nothing more complicated than create a new BusyBox pod. So I'm just going to create a random container to make sure everything is working. I'm going to create that new pod, check for errors, and update my internal metrics. And that's it. Because this is a short demo, it's a relatively short talk. So that event that I'm receiving, the custom resource specification that I have, all of the YAML that my end user provides to me, is defined by this type. So there's kind of the default metadata that Kubernetes needs. What type is it? What is the name of it? What labels does it have? And so forth. And then any custom inputs that I want the customer to be able to specify in their YAML or in their JSON that they're providing me, I can provide in these structs. And then the status of that running system, I can provide in my status definition. And then the actual code that I run is creating a new BusyBox pod. And if you look closely, what you can see is that I'm just taking the YAML that Kubernetes usually lets me use using Kubectl, and I'm converting that into Go. So this is just the Go version of the YAML that you're already familiar with. And then here's the actual pod specification, which is just that section of your YAML that is actually pertinent to what I'm trying to run. This is the actual container that's going to get launched. So now I'll go run this in my Kubernetes cluster. This is literally the Kubernetes. I mean, this is a video, but this video was taken from the one that runs in my basement. So I'll create all of the accoutrements that it takes to run my custom resource in my controller, and I'll push that up so I can see here I have my demo controller, and I have a demo service for it, and that deployment that's managed. And now I'll create an instance that's my example of it, and it's creating an instance of type demo. And if I look, I can do a Kubectl get demo, I can do a Kubectl describe demo, and I can see what it is I applied to my cluster. But I'm just seeing the demo, I'm not seeing the actual pod that I created. When I do my get all, I can see here's that pod that my demo actually created, this BusyBox pod. So the demo was really quick. I know it was a video, we didn't have a ton of time, but everything that I just showed you, you can do. You don't need any documentation other than really the README of the operator framework GitHub page. So luckily, beauty of open source, we've already documented that whole demo. You can go fire up your laptop. You need to install Go. You need to have a Kubernetes cluster, Minikube, or GKS, or whatever you want to use. You can go through the instructions, install the operator SDK, which is relatively easy, just installing a Go binary, and then you can run through that exact same demo and see it working yourself. Some practices that we've learned, we've been doing this for about 4 months. Some practices that we've learned is from the type spec, start with what your customer should know about the thing that you're actually trying to do. Don't try to port Kubernetes vernacular to your customer's vernacular. Do the reverse of that. So start with what your customer needs to actually specify to make your thing work, and then us, as Kubernetes developers, we're going to translate that into the Kubernetes nouns and specifications that we need. We think you should package the operator. Helm is the most popular way to do that. I don't have any official advocacy for Helm, but it just seems to be the most popular. Always be considering as you create your type spec how you're going to compare one thing versus another, because that's your main job in the operator, is to figure out what my current state is and how I can create that delta to get to my desired state. And the last piece that I think is pretty important is I don't recommend using the operator SDK directly when you're making calls to Kubernetes. Go in testing, have a weird relationship where everything needs to really sit behind a mockable interface in order to properly unit test it. I have a quick example of that, but you can review this later. You can come talk to me about how to do this. But essentially, I'm just putting the operator SDK behind an interface so that I can create unit tests that don't require a Kubernetes cluster. That's my talk.